All right, guys, it is Miss Humanek here, and today we are going to get started on Unit 10, and we are learning about solving quadratic equations. So the first thing that we're going to talk about is what does it mean to solve a quadratic equation? Well, guys, basically what it comes down to is we want to find the values when x is when the equation is equal to 0. So that's either going to look like y is equal to 0 or when f of x is equal to 0. So officially, we want to say to find the values of x where the equation is equal to 0. All right? And basically, another way to say it is this is where the parabola, because remember we're dealing with quadratic functions, touches the x-axis. So anytime that y is equal to 0, okay? So we can do this a few different ways, and these are all different. We like this acronym, okay? ROXX. And guys, this is going to help us when we are trying to solve our equation, because this will help us remember all the different names that we can do for different things, okay? So the first thing that we can call it is we can call it a root, all right? The roots. If we're asking for the roots of a function, we're asking for you to solve it. If we are asking for the zeros of a function, we are asking you to solve it. If we are asking for the x-intercepts, of the function, then we are asking for the solutions, all right? And then the last one, I do like this one as well. If we ask you for the solution to a quadratic function, then we are asking you to do it. And so basically though, guys, this is all, when we're talking in terms of quadratics, these are all where the graph hits the x-axis. And so guys, these can all be written as x equals a number, or they can also be written as the value like x0 as an ordered pair. Okay, and so there's a few different number of solutions to a quadratic equation. So we're going to talk about there's actually 3 different types of solutions here. Okay, and so the first is something that you will probably see most commonly, and it's when the parabola goes through either up or down through your graph. And in this case, it hits our x-axis twice. So there would be 2 solutions, all right? In another case, we would be here, and let's say our parabola hits the, I'm going to get a different color here. Let's say our parabola hits our x-axis one time. The vertex is right on the x-axis. If that is the case, if our vertex is just right on the x-axis, then in this case we have one solution, or one root, right? So this would just be one solution, okay? I'm going to write it as a number 1 so you're not confused. It is one solution. And then guys, also, this can also happen where you have a parabola that actually does not go through your x-axis at all. So it never hits the x-axis. In this kind of case, what happens is that there are no real solutions, okay? Because it doesn't hit the x-axis. It never hits the x-axis. So these are the 3 different types of solutions. All right, now we are going to, on this one, guys, you can find different solutions different ways. In a graph, you can do it in a graph. You can also do it in a table. That's what we're going to do, and then you can also just do it straight from the equation. So first, we're going to look at it from our graph, okay? So in this case, we're going to look here and we say, oh, look, here is one of our solutions. Here's one of our solutions because that's where it hits our x-axis. Our y value is equal to 0 at 0, 0, and negative 3, 0. So we would write negative 3, 0, and, or I guess you could do the little and sign, 0, 0. All right? And you could also write that as x equals negative 3 or x equals 0. You could write it either way. All right? In this case, we're looking here, and we say, oh, it only hits it that one time. So our one solution is 2, 0, or x equals 2. You can write it either way. And then on this last one, we look here, it hits it again at 0, 0, and now at positive 3, 0. So we would say 0, 0, and 3, 0. All right, so it's in both of those spots. You could also say x equals 0 or x equals 3. All right, guys, so those are all different ways that you can identify the solution from a graph. This is probably the easiest way. You can just look at your graph, find your x-intercepts, all right? So that's the biggest thing. You want to find your x-intercepts. All right, if we wanted to identify the solution on our tables below, what we can do on this table, we want again to find our x-intercepts. But in this case, what we can do in order to find our x-intercepts is we want to find or locate where y is equal to 0. Y is always going to be equal to 0 at your x-intercepts. So on this first table, we're going to look here and we say, okay, so we don't look at our x's, all right? There is an x equals 0, but we want to find where y is equal to 0. So we find it right here. Boop. So that is one of our points. And we find it right here at 2, 0. All right, so this would be negative 2, 0 and 2, 0. You could also write it as x equals negative 2, comma x equals 2. You could write your solutions either way. Now, one thing that's important to notice is this right here is our y-intercept. All right, so this is not a solution. So when our x is equal to 0, that would be our y-intercept. We are trying to find our x-intercepts where y is equal to 0. All right, y'all? And then at the next time on our table, we look here. We want to find where y is equal to 0. So I'm going to go down here on my y. There it is. Negative 5, 0. So that means, and it doesn't happen again. So that looks like that is our only solution at negative 5, 0, or x is equal to negative 5. All right. And then we have, let's see here. And then on our last table, we want to look x and y. We want to find where y is equal to 0. Well, look, it starts at 10, goes to 7, goes down to 6, then back up to 7 and 10. So it looks like it's never going to hit 0 because 6 looks like it's its lowest spot. We do have an y-intercept, but we don't have any x-intercepts. So guys, there's no, since y, so in this case, there's no real solutions. And that is because y never equals 0, all right? So if y never equals 0, then there's no real solution. So that is how you do it if you're given a graph or if you're given a table. Okay, so let's move on to page 2. For page 2, we want to look at this. So guys, one of the easiest ways you can solve quadratics is by doing it by graphing, okay? And what we do here is we can graph our quadratic and see where it crosses the x-axis. So guys, the very first thing you do when you are given a quadratic equation with an x with that square in there, the very first thing you want to do is you want to graph it in your calculator just to see what it looks like. So on this first one here, I'm going to say, okay, y equals, oh, I got things in here, I'm going to clear it out. We're going to say y equals -2 parentheses x minus 3 squared plus 8. So I just want to see, does it cross our x-axis at all? Yes, it does. It crosses it twice. Wonderful. But let's go ahead and use that and we can graph it. And so guys, what we'll remember when you're given it in vertex form, you want to, or actually, even if you're given it in standard form, you want to identify the vertex from the equation. And remember, if you're given it in vertex form, you can just get it from the equation. If you're given it in standard form, you can use that axis of symmetry, the x equals -b over 2a. And then, once you know the vertex, graph on your calculator to find the other points. All right. So on this one, we look here and we see -2, this is x minus 3 squared plus 8. I already graphed in the calculator, but let's identify our vertex real quick. Our vertex in this case is, remember, it's not going to be -3. Our vertex becomes a +3, 8, our h and our k. So I'm going to go ahead and say +3, and then up to 8. 5, 6, 7, 8. And then once we have our vertex, you graph it in the calculator, and I go to my table here, and I need to find my vertex of 3, 8. There it is. I like to put my vertex right in the center of my calculator. That's 3, 8. We can go here, we can graph it again at, what is that, 2, 6. And 4, 6 over here. And then 5, 0, look at that. And 1, 0. So we actually see those in our table, 1, 0, and 5, 0. So if I was going to graph my parabola, I can kind of, should have made it a little curvier. There we go. Okay. Sorry, this is not the prettiest parabola, but there we go. And we can see that these 2 points right here are my x-intercepts. So my solutions in this case would be, oh, I graphed that wrong, didn't I? It's supposed to be 1, 0. No wonder it looks odd. Not 0, 0. My bad, guys. Ignore the 0, 0. It's 1, 0. There we go. So it is 1, 0, and 5, 0. You can also see that in your table, that it's 1, 0, and 5, 0. Sorry, guys. I was wondering why the graph looks so off. So we want to pay attention to not this outer line, but right here. That looks so much prettier. 1, 0, and 5, 0. And remember, you can also always write it as x equals 1 and x equals 5. All right? Okay, for our next one here, let's go ahead and identify our vertex. So our vertex in this case would be, our x value would be -4, and then our y value is also -4. So I'm going to say, all right, -4, -4. And then we can go ahead and we can graph this guy in our calculator. So I'm going to clear out the previous one, parentheses x plus 4 squared minus 4. And when we graph that, we see it right here. All right, and then that looks pretty good. I'm going to go to my table. I'm going to go find -4, -4, 4, -3, 3, -2, 0. I think that's what we want. -1, 5. Okay, I'm going to go the other direction. -5, 3. Yay! -6, 0. -7, 5. All right, so this one looks better than my last one. I'm going to go ahead and draw my little parabola here. Okay, and we can see that our x-intercepts, we can also see them on our table here, -6, 0, and -2, 0. So that's -6, 0, and -2, 0, or we can say x is equal to -6, and x is equal to -2. All right, so that is how we find our graph here, okay? And we can do that for each of these. And what's really neat about these as well is, guys, if you don't have a graphing calculator at home, you can also do these on Delta Math. So I'll do these next two on Delta Math. And so, guys, our vertex in this case, well, guys, if we were looking at in vertex form, there's nothing in the parentheses, and there's also no x. So that means our x value is 0, and our y value is -8. If we didn't remember that, we could also say, remember, our x is equal to -b over 2a, and our b is the coefficient to our x, which is 0 over 2 times 1/2, which is still just equal to 0. So if we didn't recognize this as vertex form, we could still plug it into our equation, and we could see it that way. So I'm going to go ahead and 0, -8 down here. And now what we see is okay, y equals, and we have, let me see, I'm going to clear that. I'm going to say 1/2 x squared. Oh, I said that I would do this on Delta Math. On Desmos. So I'll go ahead and do that right now. So if we wanted to do this on Desmos, we could go ahead and we could type in y equals 1/2, oh, not y minus, y equals 1/2 x squared minus 8. And when we see that, we can see all these lovely little points. And guys, one thing that's kind of neat about Delta Math is you can hit this little gear button, and it edits it, and you can turn it into a table, which is really cool. So you can actually turn it into a table for you, and you can graph those points right there. So that becomes, what is that, 0, -8, and then I'm going to say -2, -6, okay. And then I want these points up here. Ooh, look at that. It even gives them to you. That's awesome. So -2, and then +2, -6, and then we're also going to do 4, 0, and -4, 0. So if I graphed this picture over here, do it with my blue one, we would see it kind of go through our parabola. There we go. It always looks prettier, I feel like, on my second side. But there we go. And so then we can see that our y-intercepts, or our x-intercepts are right there. So they would be at -4, 0, and +4, 0. All right, and so that would be x is equal to -4, and x is equal to +4. So we could write it both ways down there. And then our second one here, y is equal to negative parentheses x minus 2 squared. Well, in this case, our vertex would be, well, the thing inside the parentheses is it would make it turn into a +2. And then really there's being nothing added here, so it becomes 2, 0. So my vertex is right here at 2, 0. So if we typed this into our Delta Math here, I'm going to go ahead and clear this out. And I'd say y is equal to negative x minus 2 squared. And that's it. Then we see these points right here. And if we want to go ahead and see this as a table, we can do that. So I can convert it to a table and see all my points right here. And I want to move these up. So if I do that to 3, it gives me new points, and 4. That is so cool. So we can kind of see our points around it, and so I'm going to say that's 1, -1, and then 0, -4. Oh, and so for this particular one, you notice that the vertex is right on our x-axis, so that means that it only has one solution in this case, all right? So in this case, we see that our solution is 2, 0, or we can always write it as x equals 2. And the important thing to notice about this is that if the vertex is on the x-axis, there is only one solution. I am having trouble with my spelling today. All right, so there's only one solution. So if the vertex is on the x-axis, there's only one solution. So guys, that is how we can find our solutions by graphing.